time for a bad guy to do bad stuff. So this is also something you could have in mind if you think about your toolbox, how to secure communication. Let's go one step further. Let's go back to the deck. So this shared access signature, this SIG thing, I told you stay with me. Let's compare this SIG thing with the shared access key, the symmetric key that we have inside of the connection string. And if you compare those two, they're completely different. What have we done here? What is the SDK doing on our behalf with this symmetric key? And here's something very, very interesting. So the SDK is using this symmetric key to calculate a hash over a magic string. So the SDK takes the IoT hub name, takes the device name, takes the session expiration time, puts everything in a magic string, hashes this magic string, and this is the hash from the magic string. Together with this information, the IoT hub on the cloud side can double check, is this signature created with a valid symmetric key, and is the time still okay to accept this message? This is happening behind the scenes. If you're interested and if you're joining the IoT hack, let's talk tomorrow in depth. I will show you all the goodness in the SDK, how this is done, what cryptos are used. It's an HMAC 256. But for the moment, just stay with me and say, this is something which is calculated based on that symmetric key. What can we do here? What is possible? When we go back to our previous example, we have created a device. We have created the symmetric keys. We have copied the symmetric key to the device. The device is using the symmetric key to calculate a shared access signature token based on that symmetric key to authenticate, authorize this message with a timestamp. How trust? But then we use this method, this way of authentication to improve the security here. Because this could be a brownfield approach. Because my approach here is now, for whatever reason, I have existing customers back me to connect them. I told them that it is a security threat. They say, yes, I accept this. Here's my signature. I accept this solution. But please, please make it a little bit more secure. Is there anything we can do? Now think, by knowing what is really going on behind the scenes, how can we improve it? Any ideas? Let me help you. Let me draw here something. Oops, this is not what I wanted. This is what I wanted. So, what do you think if we do not transfer the symmetric key to the device? If we say we keep the symmetric key somewhere in a easy to protect or more easy to protect area. We keep it maybe in the cloud. And when the device wants to connect to one of our endpoints, when it wants to ingest something, he first reaches out to a service, maybe AMQP, maybe MQTT, maybe HTTPS, maybe something. And this service here takes the symmetric key, calculates a shared access signature token with a lifetime maybe of 60 minutes, 30 minutes, 5 minutes, you name it. And now we just have the shared access signature token on the device. What does that mean? This device is still a very, very weak device. But that device now has just a temporary badge, which allows him to be in Mumbai at the hotel from the 4th till the 6th of June. Then this token expires. This token expires as well. What can the device do? First of all, it gets an error message from IoT Hub saying, your shared access token is out of time. You are no longer allowed to communicate with me. Now the device can reach out to this endpoint again and ask, hey, please, please give me a new shared access token. And now you can decide in that functionality over here. So, oops, let me go back. No, let me go forward. In that functionality here that you have developed, okay device, you want a new shared access signature token. Let me go into the telemetry history in my big data store and let me check how you have behaved the last week, the last day, because I know you have a lifetime token of a day. What have you done last day? What was maybe your IP address within this day? And I know you're in a stational, you are in a factory floor, you can't move. And now you have an IP address from a different country. Oops. Is it still you? Think about a connected car scenario. Connected car, when the device, the connected car, reaches out for a new shared access signature token, maybe in the back end, you just ask for GPS. Dear Mr. Device, please send me your device, not your device, your GPS coordinates, longitude, latitude. Oh, you are on the way to Russia? The last year you were just driving in the area of Munich and now you're on the way to Russia? Okay, this is at least something which is not usual. What can I do? The backend now can decide, okay, cool, I don't know what is going on with you, this is at least unusual. Let me send you a new shared access signature token with a lifetime of 3 minutes. And by the way, this is your new connection endpoint. And you redirect this at least not so secure device, you're not sure if it's still okay or not, you redirect to another endpoint where you do much more data analytics, where you look much more into the incoming telemetry data, and maybe you reach out with a multi-factor authentication, maybe using a phone, an SMS, an email, to someone who owns the car, saying, hey, we have detected that your car is driving in Russia, Poland, Germany, France, India, Pakistan, wherever. And with the multi-factor authentication, someone said, yep, that's okay, because it's my wife, and she's driving, or it's my daughter, it's my son, this is okay. And then in the back end, you get this okay again. You have here just a lifetime of 2 minutes, 3 minutes, 10 seconds, 20 seconds. He will come back to you, he will say, okay, I have now proof that what you're doing is still okay. Let me send you back to the real, and here's again a token for an hour, for a day, for 10 days, for a week. This is just an idea. This is just an approach where you can improve. I don't say you make it secure. I just say you can improve security on devices where you do not have a hardware root of trust silicon support.
That is the case. For the initial contact also, that hardware need a identification to reach to the first server. Right? So that means the program what is going to reach to that server has to take up a token again to identify, right?
It's a good question. So when this device connects maybe for the first time, how do I ensure that it is the device it claims to be?
Right. So that means certain kind of key need to be anyhow had to be hard-coded.
Exactly. Maybe not hard-coded, maybe it's a certificate which you ask your silicon vendor or which you deploy on your own to that device. If you're going on a high-scale scenario, we have a service called Device Provisioning Service who can deploy this for you. And then you have this first-time contact certificate. This is used to authenticate against this endpoint. And the next thing what you do, you refresh the certificate or the shared access key, the shared access token, again with here, and then you check the next one. And you have here an exchange of crypto material. And again, it's not safe. It's just safer.
Yeah. Okay, so you are talking about the bootstrap concept of that one, bootstrap server, or you are talking about that one? So that one thing, so if you are using any hardware chip, so as you mentioned, if you are using any hardware chip to encode such kind of a key.
Yep, so the security chip on the device, on the silicon.
Right. So those chips, for example, in the case of TPM kind of modules, so those modules are able to rewrite, because usually those modules are something fixed storage, right?
There are multiple things, so there are multiple chips. Some of them are rewritable, some of them are once just writable. So there are multiple versions of those chips. And depending on your solution, on your use case, on your business case, just look for the right secure silicon, for the right hardware root of trust.
Okay.
Okay? Whoa, I'm running a little bit out of time, so I have to speed up a little bit. But I think it's interesting at least. So because nobody has fallen asleep already, and it's already 8:10, so I hope it's still interesting. And if I take too much time on a specific topic, hey, please let me know. If you want to go deep somewhere else, please let me know. So that I don't tell you something where you say, hey, Robert, blah, that's really not interesting. But let's shift gears again. We talked a little bit about hardware root of trust. We talked a little bit about a brownfield approach. And we talked a little bit about a greenfield approach, what we can do to at least have this hardware root of trust somehow addressed. Remember, we have 7 of those properties, and we have the hardware root of trust now addressed, let me say, 5% or 10% of it. So there is still a lot of things to do, but that will take, I would say, the next 24 hours to talk about all that stuff. And I'm here. I can't fly home, so if you're interested, I will stay here as well, but I think we focus now on something different. And what I want to focus with you on something different is, again, Microsoft IoT cloud solutions. And the hottest and greatest and coolest what we have right at the moment is the so-called intelligent edge. As you know, we already have a very intelligent cloud, very powerful, scalable. We run Linux systems in the cloud. Microsoft runs Linux. We have really an intelligent cloud. Now we have the intelligent edge. What does intelligent edge mean? Well, with intelligent edge, can I still? Yeah, I can still draw. With intelligent edge, we can say some processing functionality is running right at the moment in the cloud. Some custom code that you have created, some stream analytics job, some cognitive services, some AI modules. They're running in the cloud right at the moment. But tomorrow you decide to run your artificial intelligence, your machine learning module on the edge. Because maybe you have sold something to Russia, and in Russia, it's not allowed that data leaves the country border. I don't know if you have something similar in Asia. I've heard some stories about Japan, but I'm not sure. But you could imagine, for some reason you decide, I want to run this now on the edge. Because maybe I do not want to send all the streams from surveillance cameras, which are not attacked by Mirai, from normal surveillance cameras to the cloud anymore, and then do the face detection in the cloud. I want to do the face detection on the edge, and just if I have detected a face, then I want to send the picture for further processing. That would reduce your pressure on having a very, very big bandwidth to the cloud dramatically. And we can do this. This is great. This is cool. Is it? When I started the talk, what was the first I really tried to deliver as a message? Think security first at the day. When you stop the day, you think security. And in between, you just think security, security, security. Now let me add, let's think privacy. Let's think, hey, this is my IP. This is my code. Stream analytics. Machine learning module. This is my code. And all of a sudden, this code is running on the edge, on a device which does not have hardware root of trust. And here's my machine learning module where I have paid hundreds of thousands of dollars, euros, yen, whatever, to get all the data scientists in the room, figure out the right module, make the model work. And now it's here on that chip, and everybody can go into the factory and can steal it. Well, this is not really security, this is IP protection. But as I've mentioned, we think security in the morning, in the evening, and in between also security. Now let's also think privacy and IP protection. And now if we have, which is a good thing, don't get me wrong, it's a very, very good thing from a toolbox point of view to run edge modules, to run compute power on the edge. But your IP is now leaving your fully controlled cloud boundaries and is going somewhere else where you do not have control over the hardware. Oops. So, to the guys who have been the last 2 days in the hack, what have we done today? We have created edge modules. We have downloaded edge modules. We have given IPs where we have spent maybe thousands of dollars, euros, yens, you name it, and we have simply deployed it to a customer. This is something like, okay, use my credit card, dear Mr. Customer. I trust you. I know that you do it well, that you do very well with it. Do we want to do this? Who wants to do this? Because then I will ask for your credit card because I'm very trustful. No, we don't want to do this, for sure. We don't want to do this. And for all of you who have not had the chance to join this hack, what is this mystical intelligent edge? What do we do from a technical point of view? How am I in time? Do I have a couple of 10 minutes? 15? Great. 5? Ooh. Okay, I will speed up. So this is a Docker environment. So we have some Docker agents, we have some Docker executed hubs, some Docker executed messaging queues, more or less. We have here an IoT hub proxy running on the edge. And then we have also Docker containers, which are running in the Docker container. And those are the modules, your machine learning modules, your cognitive services, your custom code. This is more or less from a technical point of view what's happening. If you're interested, I'm also tomorrow here. We can go there very, very deep. What do we do as Microsoft to help you now protect, first of all, the security? Because now this is a hardware module. It's no longer just a telemetry. Now it is even your predictive maintenance code. Now it's even your face detection code. Now it's even worth, when we think about attack surface, for security threats. This is a gold mine for every bad guy. What do we as Microsoft do to help you protect this? Well, what we as Microsoft do is, what a surprise, we want to have a hardware root of trust. We want to have a secure device where you have security, where we can store credentials, where we can somehow ask the silicon, please help us to protect the assets which are on that device. And to go a little bit deeper, we have, and this is not yet in the public preview that you have seen, but what you will see, I guess it's for GA. Don't talk to my manager. I don't know if it's for GA. It will come. So we have something what we call the Azure IoT Edge Security Manager. And this Azure IoT Edge Security Manager will give you 3 promises. The standard promise, which is we don't promise anything. The secure element promise and the secure enclave promise. What is this? Standard promise. Typical layout of an edge module. So we have a security daemon, we have an HSM, so hardware security platform abstraction layer, and we have a file system. This is part of the edge runtime, of the secure edge runtime. But because we do not have support from silicon, we can't really protect anything. Because if everything is on an SD card and somebody decides, hey, I take this SD card, you're gone. And again, I'm over-iterating. You can encrypt the SD card. But where do you store the key to decrypt that? It's also somewhere in memory. I can easily attack that. But it becomes interesting when you have the secure element promise, where you have at least some security, hardware root of trust, silicon functionality on your device. Because then our secure element promise gives you the security to protect connection strings, certificates, and so on. And this is now, by the edge execution runtime, stored in the security chip of your hardware. This is already pretty good. But I've threatened you with your IP. Do you really want to store your machine learning model on something which is very, very easily vulnerable, or which is vulnerable and very, very easily attackable? And if you go for the secure enclave promise, what we also will give you with the edge runtime, here we also have a secure compartment. We have here a secure sensitive logic execution layer. If the silicon supports it as well, then we support it also. That means when you have your highly confidential, super secret machine learning module developed and you download it to the edge, or more or less you ask the edge to pull it from your container registry, technically speaking, we take care in the edge runtime, if you give us the right information and the silicon supports it, that it will be executed in a secure sensitive logic compartment, which is completely silicon isolated from other modules which are not that sensitive. And this is the promise that we give you. Hardware root of trust is again the base for that. What is the challenge here? We wouldn't be Microsoft if there would not be a really, really big challenge. Price tags. Not Microsoft price tag, silicon price tag. When we start here and we're going all the way up to the right to the secure enclave, at least you have 10 times the cost of the silicon. Sometimes it's up to 50 times, 50 times the cost. Whoa, who can afford this? Nobody. No, it's not that way. Again, I had a similar discussion today afternoon with some of the attendees. The discussion was the devices need to be cheap. Cheap, 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 cheap. And I agree. But now let's look a little bit different. Let's call those devices no longer devices, call them sensors. And maybe we have 10 sensors, and they do not directly communicate with an edge, with an IoT hub, with the cloud. They communicate to a secure edge device. And now at least you have the communication from these cheap, 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 cheap sensors with a somehow, for sure, more expensive, but for an intermediary. And here you can have your security magic in place. This is just, again, a best practice, an idea. You always have to think twice, does it fit to my use case? What is the price tag? And we as Microsoft, we are here to help you with these ideas. This is more or less what we have done yesterday, today, and what we will do tomorrow with all the attendees of this hack. And now, because I'm running out of time, 5 minutes? Okay, he gave me additional 5 minutes, and this is really the last what I want to talk with you about. Remember the 7 properties of a secure device. I told you we need support from the cloud, we need support from the silicon vendor, and we need support from the OS vendor. Who in the world, which company in the world can give you this? Which company owns silicon deployment, silicon development, is running a very, very high-scale cloud, and has also a highly secure operating system? Windows, highly secure. You name it, you say check or no check. I will not say check or no check. Silicon, Microsoft, beautiful Surface devices, Surface hubs. So we have experience in silicon, but we do not produce IoT silicon. This is not something we do. But what we have done as Microsoft, and I'm pretty sure you heard about it, is Azure Sphere. Azure Sphere is something that we as Microsoft have given to the public or announced publicly. I think it was built, this year's build, or a couple of weeks before. And what is Azure Sphere? Azure Sphere is a promise for support from the cloud, support from the operating system, support from the silicon for security, to support the 7 properties of security. When it comes to the silicon, we have a design, a silicon design, which we give royalty-free to everyone who is interested. And everyone who is interested can take this design, can build silicon based on this secured MCU design, microcontroller unit design. And we have certification programs so that you, as maybe not a silicon producer, but as software orgs, as software companies who are building software, you go to a silicon vendor and can say, hey, silicon vendor, Azure Sphere, are you certified? And if they say yes, you have the hardware root of trust to at least fulfill one of the properties of a secure device. Secured OS, secured operating system. The next promise and the next thing we really, really need to have a secure device. What do we do as Microsoft? And here's the thing what we're doing. We have a new operating system. Azure Sphere is also an operating system based on a Linux kernel. So we have now Microsoft, take this, Microsoft has now a Linux distribution which they have specifically designed, which Microsoft has specifically designed and developed to meet the security needs of an MCU chip. We give you a promise that this operating system supports the silicon functionality of secure enclaves, for example. So if you take Azure Sphere hardware, we have a promise that your software, the stuff that you are developing, first of all, can be sure that the chip was booted with the BIOS version it should boot. It is booted with the operating system it should boot. and it is running the code it should run and not something modified. So we have here secure MCU with an operating system which is specially developed to support this silicon chip. And then when it comes to the cloud, here we have the promise to update this silicon, this operating system which uses the silicon, also with all kind of other logging functionalities, detect threats, for 10 years. Which operating system vendor gives you a guarantee for an operating system to keep this operating system alive for 10 years, support it for 10 years with security updates, and keep it secure in combination with the cloud? I know one, maybe you know others, but this is unique as far as I know. And this is the promise from Microsoft. This is Azure Sphere. You have support from silicon, with certified silicon. You have support from the operating system, Linux-based, and you have support from the cloud for a very, very cheap price tag per year per device. I think it's, no, I don't say a number. I'm not a salesperson, and to be honest, I have no real information how expensive it is or how cheap it is. But this is also something we as Microsoft give you as a tool in your tool set to build a secure solution. And as far as I know, that might change because this is super hot and new, that we might be able to run an IoT edge on this secure hardware. Right at the moment, we can't do this because the operating system, the secured operating system doesn't support Docker. So we think about this more as the sensors, which are vulnerable as well. And then, when it comes to the edge, we expect, or at least right at the moment, we suggest something which has a little bit more power, which has a little bit more memory, which can be easily protected as well. And this is really my last slide. I'm running over time. Sorry for that. But I hope at least it was somehow interesting for you. We talked when it comes to security about the threats. And I just gave you 3 examples. I have a full bunch of examples, or a lot more examples, about the security world we are living in. Petrochemical plant was attacked. Whoa. We talked a little bit about the 7 properties of highly secure devices. We talked a little bit about this authentication mechanism, how it works behind the scenes, and that it might be just a small piece to make brownfield a little bit more secure. I don't say it's a silver bullet. It's just a very, very small piece, but at least it gives you some arguments for brownfield. We talked a little bit about the Azure IoT Edge and what we are doing when it comes to the Edge runtime. And we talked at the end about Azure Sphere. And by saying that, if there is just one thing you want to take out of this talk, one thing I would really like you to remember, 7 properties of highly secure devices, AKMS, 7 properties. Look at it, download it, study it, pray it, read it in the morning, in the evening, and during lunch, because this is the base. And by saying that, thank you very much for having me here in Mumbai. It's a great pleasure for me being here, and I hope at least this was somehow interesting for you. Thank you. So I know we are over time. If there are questions, I'm very happy to take them.
When we already have IoT devices.
When you say IoT devices, could you give me an idea what you mean with IoT devices?
In your Azure hub, you have IoT devices. I can create a device, I can connect a device which is in the field.
Yeah.
Versus you have IoT Edge, which is again kind of used for the same purpose. Yeah, I just wanted to understand a little more, where should we use what?
So, a typical IoT device, which we can create in IoT Hub, is something which can send telemetry, which we can send properties, where we can send commands, but it is a device which cannot execute logic on the edge. When it comes to an IoT edge, this is something where you can decide by configuration in the cloud if some code should be executed in the cloud or at the edge. That's the major difference between those 2 devices. So a device which can run compute, which can execute code, and a device which has a BIOS burned in and can't dynamically download something from the cloud where you do not have this possibility to really put it for computation to the edge, to the device.
You mean a camera like which has a face recognition running on the edge? We can extract data from the cloud for face recognition.
Let's take this surveillance camera example. We have a device which is a surveillance camera. If we treat this device as an IoT device, the camera has a fixed set of BIOS functionality. And then it sends maybe telemetry streams, live streams to the cloud, and then the analytics is done in the cloud. Or you have a very professional camera, and in the BIOS you already have some modules, some whatever. And now you have to update this module who detects faces. What do you do if you just have an edge, when you just have an IoT device? You have to send a new BIOS version. More or less you shut down, you install, and so on and so on. And when you have an IoT edge, you can say, for this kind of devices, I want to run this cloud functionality now dynamically on the edge. Oh, it's not working. Let's go back to the cloud without modifying a BIOS, without modifying anything. That's one piece. The other piece is